What's up, y'all? I wanted to thank you for joining the waitlist, and as a bonus, I'm gonna release one of the materials that I'm most excited about in Unreal Fundamentals completely for free, no strings attached, and I'm gonna include the video along, and that'll play right after this, so download the master material cheat sheet and use it in your own projects. And we're already running out of spots on our Unreal group mentorship program where you get one-on-one weekly feedback on your assignments with me. So if you want to schedule a call and talk with me or someone else on my team, you can schedule a coaching call below and we'll see where you're at. We'll find out if you're a good fit and we can enroll you in the program one-on-one. So please use this cheat sheet as much as you can. This is the thing I wish I had when I first started learning Unreal, so I hope you enjoy it. Thanks. I've included this material graph cheat sheet, and this is a material not meant as something that you apply, but as a resource for the most commonly used nodes in your material graph that you'll need to use. And it's sorted by the most important at the top and the more complicated and more niche the lower down you go into the graph. So let's walk through what's inside this template and what you should be taking from it, because this was built in a way where all of the information is included with all of these nodes. So you have a handy helper for every single node that you see, but we can also just copy and paste these into our master material graph. So to start off, on the top left, I've included all of our constant vectors. So again, a vector is anything more than one value. We have our scalar parameters here. I'm just pressing 1 and clicking down to create a scalar parameter, but I can hold down the 2 key and click to create a 2 vector. I can hold down the 3 key and click to create a 3 vector and a 4 vector as well. And for any of these, whether it's a scalar or a vector, we can right click this and convert it into a parameter. So that's what we're seeing on the right here are the parameters. And again, just as a reminder, parameters are what will show up inside of our material instance. So it's the things that we can change on the fly in our material graph. So we have vector and scalar parameters. We also have texture sample parameters. So these are the textures like our albedo, roughness, or our combined maps like the ORD maps that you'll get with your Quixel assets. So next to this, I have our most common math nodes, which are add, subtract, multiply, divide. They work exactly how you'd think, and these are the order of operations for the subtraction and divide, just in case it wasn't obvious. But for any of these math nodes or any below, if you hit Control and Alt, you'll see that you get a tooltip that comes up and gives a lengthy explanation of every single one of these nodes. So the problem I found at first was knowing what these nodes are in the first place. But you can build almost any material out of just these few nodes, especially when you're just getting started. But just know there's lots and lots underneath, but these are the most important ones that you need to know. So these are the math nodes. These are how we can take different inputs and do simple operations between them. We also have some image manipulation nodes. So it is a bit weird and it's completely backwards in Unreal that the way you add saturation or desaturation to an image is through a desaturation node. So if you wanted to add saturation, you actually have to go into a -1 value, and that will make your images more saturated. I'll explain why in just a minute. For inverting values, you have a 1- node, so you have to type in 1-, and that's the node that will come up. And then there's also a cheap contrast, and there's also cheap contrast RGB. RGB for a color image versus cheap contrast, which is just for a single color channel. Now we can also remap any of our values, so we can clamp our values between two numbers. Now the saturate node you'll actually see here, and what this does is it just clamps between 0 and 1, but if you hover over this, you'll see that it's completely free on modern graphics hardware, which means it doesn't cost anything at all to compute. And this node existed first, which is why we have a desaturation. So this is more of a game dev specific to Unreal thing. So just be aware of that difference. And then we also have some other math nodes like the absolute value, where even if a number is positive or negative, it'll return the positive absolute value. And then you can also round your values down by getting rid of any decimal points afterwards. Ceiling will round it up to the ceiling of the nearest whole number, and the floor will round it down to the floor of the nearest whole number as well. Now, if you want to reroute these pipes, it's pretty simple. You can drag off any of these pins and create a reroute node, but these have some pretty funky behavior, some odd keyboard shortcuts that you'll want to remember. So if you have an existing pipe like we have here, if you want to create a reroute dot, you'll hit Alt and then double middle mouse click to create this. Again, it's weird, so I just included all the hotkeys here so you don't have to remember them at first. This does become second nature, but It's very odd and different than all the other main softwares. So that's why I include it there. Now, if you control and left mouse click here, that's what you need to do to move this dot around. So if you just click on it, it'll just drag off a pin. You have to hit control and left mouse click to push this around. And then you can also create these invisible reroute nodes by naming them. So if you right click on any dot here, you can convert this to a named reroute node, and I'll just hit F2 to rename this, and we'll just call this renamed reroute. And what happens here is that anything plugged into this reroute node now, you can just right click anywhere in your graph and you'll have this new named reroutes option at the top here. And now you can select from any of these existing groups, and then you could plug this directly into anything inside of your node graph. Now, you don't want to overuse these to the point where it's very hard to understand where things are coming from in the first place, but these are a great tool to have in your back pocket. And then a really important note here, if you click any node and you right click it, you can start to preview this node, and you'll see it's previewing that over here. And oftentimes, if I'm previewing something in UV space, I'll switch this over to a plane or a cube, and you'll start to see what this looks like on each face. So this is a radial node, which is included as a mask. And it's an easy way to preview this in the material editor. And just to show what we might do with this, you could add a 1- node afterwards. And then if we preview this, you'll see that it inverts our masks. And a note I left here, if something isn't working, it's usually because you're sending or receiving the wrong data. You can see on this node here, it's expecting a scalar value or a vector 2 here. So typically, if you're getting errors on any of your nodes, especially these material functions, it's because you're sending or receiving the wrong data, and you just need to change how your data is being input into the nodes. So if something doesn't work, check that you're sending and receiving the right type of data. One way that we can do this is using these split and combined vector nodes, which I've shown earlier. These component masks will let us limit our vectors. So this would be a scalar parameter if we had only one output coming out here. Otherwise, it's a 2-vector, 3-vector, and 4-vector. And then we could append different vectors together here. Here's a basic example of how we would do that with a normal map, because with normal maps, the B channel is always just set to 1. So I've done this here. I've just split out from our RGB. So this would be a 3-vector coming out of the RGB channels into a component mask to just limit it to our R and G channels, making this a 2-vector. We're then multiplying this. So we could set this up with a intensity multiplier here and call this normal intensity. And from here, we could create an intensity slider for our materials. And then by appending the blue channel, we would have a complete 3-vector and RGB image that we could plug into our material. Unreal also doesn't have any options for bump maps by default, if that's what you're used to. So the way you create that is through a normal from height map. And for the height map, you have to create a texture object, which is different than a texture sample, just something to be aware of. And then you have scalar parameters, 2 vectors, which is just the texture coordinates here. And then for this height map channel selector, you would input a 4-vector, and then depending on what channel you want, R, G, B, or alpha, you would set that channel to 1. So in this case, it would select the red channel of our height map. And then for our masks, we have a couple options of the things we can create in Unreal. I would still recommend using textures instead of radials when you can, but as an FYI, materials can only have 16 image textures loaded in at any given time. So this is a way to save on image textures if you need to. Now this is what a radial looks like by default. And one node you should really know about is a lerp node. So if you're used to Nuke, this is just a key mix node with the A and B inputs flipped. But if you don't know what I just said and you're brand new to both Unreal and Nuke, then this lerp is just a way for us to use an alpha input, whether that's an image texture or a set value, and mix between 2 images. So to give you an example here, I'm just going to create 2 different 3-vectors and set one to red and one to blue and plug that into our A and B inputs. And now I'm going to plug the radial mask into the alpha. Now we're still previewing our radial here, but we can see that it's outputting white around the edges and 0 or black inside the center. So I would expect if the alpha is 1, it will show B. I would expect this to be mostly blue with a little bit of red in the center. If I set the red to a darker color, you would see that is essentially what's happening is we're interpolating between the A and the B based on an input. And again, we could unplug this alpha and it would just mix between the two. So we have red and blue making purple. If I set the alpha to 0, it'll be red, it'll be the A input. And if I set it to 1, it'll be the blue input. So I'm just gonna stop previewing that node. And then we have two 3D masks. So this sphere mask is used in 3D space. It'll create a 3D sphere, which can be used for different additive effects. We also have our noise node here, which just creates this really small micro noise. Something to note here that all of the details are going to be inside the details panel here. They're hidden, so you can't set these with parameters. But if I change the scale down to 0.1 instead of 1, you'll see it has an inverse relationship. The smaller I make this scale, the bigger the noise becomes. Setting it to 0.01 makes a cloud texture or a noise texture, and you have all the typical things you'd associate with a noise node. And just to get through the last of our list here, a couple things we have left are our world position offsets. So we'll show this off when I get to the foliage section, but you can apply offsets to your geometry inside of your material graph by using world position offsets. So grass is not hand animated inside of Sequencer. If it's blowing in the wind, you can do simple tricks using some nodes like the simple grass wind node to apply some noise running through 3D geometry. So I'll show that off in a later chapter. I also haven't touched on material functions as much, but it's just a group of nodes that we can turn into a simple function, meaning we get inputs and then we output a result, a function. So we're defining the type of inputs that we need on the left here, and then we'll get our result. If you ever want to see what's going on inside of any of these material functions, you can just double click on it and it will pop open. And this is just another material graph inside of this material graph. So it's using some complicated techniques, but a great way to start learning some really advanced techniques with absolute world position and different things with rotators and vectors is just to open up some of these more advanced material functions that come with Unreal and start to recreate them node by node. So we have the ability to select channels just like our component mask, but we can do that inside of our material instance using the channel mask and component mask parameters. We can also switch on and off different sections of our script using a static switch parameter, and then we'll get this little checkbox inside of our material instance, so it's really easy to toggle on and off. In terms of modifying our UVs, we have our texture coordinates, which is just the basic UV channel as you saw earlier, and you'll understand when I preview this. So we have our UVs, and then we can also, and some things that are common in terms of adjusting our UVs are panner nodes, where we'll change our speed in X and Y and just pan our UVs in that direction. We can also rotate our UVs around, and we can use sub UVs, which are just like our flipbooks. They are taking sprite sheets and animating through a small flipbook like that. So those are all collected under this tab here. And then the rest are our most advanced nodes. So these are just here so you are aware of them and can start to see that they exist and hopefully start to think of ways that you can use them. But don't worry about using them in your first nodes. We are not going to include any of these in this master material. But some of the highlights, the things you should know, this absolute world position is a way for us to define a point in 3D space. So a really easy way to think about this absolute world position is when I select our Manny character here, his absolute world position of his pivot point is -80, -200, 20. So if I made a 3 vector inside of here and set this to -80, -200, these would share the same absolute world position. Now you can apply this absolute world position to every pixel of this geometry in the scene, and we'll get a pretty interesting looking map because it's just data and it's very high values. And this is one of those driving forces inside of our simple grass wind. WPO here stands for world position offset, and this is our absolute world position. So these are different ways that we can move things inside of our 3D scene, even though we're just in the material graph and we're changing how the material works. We can use these to change how our materials look inside of the 3D world. And we can also get position data from our camera, our object, the object position, the actor position, even the vector of your directional light or the direction of your camera. And you can use all these different data channels in fun, interesting ways inside of Unreal. And we'll get into some more complex techniques using these later on. And then lastly are these debug nodes. Now these are definitely more helpful when you get into these data inputs and things like that, But a simple example of when you would need to see this is something like a sine node. So if you remember earlier when we set up our light, a sine node is just a waveform that's happening. You just have to input a time input into that sine. And now if we plug this into our debug scalar values, we can see exactly what the data output of this node is. And you'll see that it's going between -1 and 1, and it's making a perfect wave in between those two values. So if you ever need to debug the result of different math operations inside of your material graph, this is the best way. You can do it with scalar values, or you can do it with vectors using this debug float3 values. In our last two sections, we have some nodes that will help us create some triplanar materials. So we'll get into this again in a later chapter, so I'll just wait to explain it until then. And we also can have our materials talk to Niagara systems in specific ways. In fact, if you scroll down to the Niagara menu, you'll see that we have some special options here. But more specifically, this particle menu also talks to the Niagara system, and we can call different data like the color of the particles, our particle size, our particle radius, and we can just pass data from our Niagara system into our material graph, and vice versa. We can pass information from the material into Niagara using this dynamic parameter here. So we'll get into some of that. These are some more complex things at the bottom. You really just have to worry about these top nodes. These are what we'll use to actually create our master materials. But definitely keep this cheat sheet open whenever you're creating master materials. And this way you'll know exactly what nodes to use, and you'll get these little helper tooltips included with the most commonly used nodes. And I really hope this helps speed up how fast you can learn the material graph, because you're going to keep reusing the same simple nodes over and over again. So just getting used to them, used to the language that Unreal uses, things like how the saturate and desaturate nodes are different. Those are things that you'll get used to pretty quickly once you create a couple materials. But now that we've had this overview of the cheat sheet and we see the most commonly used nodes, let's apply that and create our own master material from scratch.